With this question, it's definitely worth reading it and having a little strategy before you start. So it's worth spending about 30 seconds just thinking about 30 seconds to a minute. What's your strategy going to be to solve this? My strategy to solve this was to think about having a trapezium rather, and then taking and working at that area of the whole trapezium, and then taking away these white sectors, which is going to involve radian measure, which we did on our course. So the first thing, to work out the area of a trapezium, I am going to need the h, the height, the perpendicular height, which I've got there. Now, this part is 3 and this part is 6. And you could do a triangle, add a rectangle, and you get the same answer. That blue line is h. And what I've got for h is the square root of 15 squared, take away 3 squared. So h was equal to the root of 216. Now the trapezium has an area of the h value divided by 2, and then add up the two parallel sides, 6 and 9. Now if you work that out, that gives me approximately 110.27. And the area of that trapezium, by the way, is on the formula sheet. And like I said, you could have done it as a rectangle, add a triangle. To work out the area of the sectors, I'm going to work this angle out as theta 1, which is quite straightforward. And I'm going to work this angle out here. And then I'm going to add 90 degrees, which is pi over 2. And then I've got my theta 2 angle as the whole of this. So, and then I'm going to use both of those with the area of a sector formula, which is in the formula sheet. So from that first one, we can just use a right angled trig and just say that cosine theta 1 is equal to 3 divided by 15. So theta 1 then becomes approximately 1.37. And I'm in radian mode because I'm using radian measure for these sectors. Now theta 2, so not theta 2, that shaded angle that I showed you up there, that shaded angle there is pi over 2, 90 degrees, take away theta 1, because we've got a triangle there, we've already got a 90 degree, so this 90 or pi over 2 plus pi of theta 1 plus that shaded one, that all has to add together to give me 180 degrees. So I've got this one as 0.201. And then theta 2 is 0.201 add pi over 2. So theta 2 is, let's just go to my calculator and work out exactly what that is. So I need to do pi divided by 2, add 0.201, and it gives me 1.772. Okay, almost there. We need to work out the area of a sector, and that formula is theta r squared divided by 2. So I'm going to do the big one, which is the theta 1, and the radius is 9, and I divide by 2, and that gives me approximately 55.5. Then the small one, now for the small one we have 1.772, times it by 6 squared and divide by 2, and this is approximately 31.9. Again, all just done on your calculator. Now I just need to finish it off by taking the area of the trapezium, take away this, the final area approximately 22.9, and I'll be lenient and give marks if you're very close to this with the rounding errors, no problem. So this is only worth 6 marks, but it kind of makes up for the previous question, which I thought was quite a very easy 9-mark question.